I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have 4 questions based on arc and central angles. Diagram along with questions is given to you. Pause the video and answer. Our approach, engaging minds, help to creatively think and solve problems. You can now connect learnings to visualize solution and provide strategic solutions. Gift of education. You can join my classes by sending an email on the address given. I can be part of your success story, build strong foundation and ensure bright future. Let's now begin with the solutions.
Here is a question based on angles at the center. In the circle, here is a question based on angles at the center. It is based on this particular diagram where in the circle D, EB is the diameter. So we are given the diameter EB. Find the measurement of the following. Now we are given different conditions. A is if measurement of angle EDC equals to 3x plus 10 and measurement of arc BC is 2x minus 10, find the measurement of arc EC. So if angle EDC is given to you, so EDC is this central angle, and the arc BC is given to you, which is right there, then you have to find the arc E to C. That's the whole idea. So that is how this time we are going to connect the central angle, the angles on the circumference, which is subtended by the arcs and the arcs themselves. Here is question number B, part B of this question. If measurement of angle BDC is 3 within brackets x minus 5 and measurement of arc BC is x plus 25, find the measurement of angle E. C. If measurement of angle E is half x minus 10 and measurement of angle C is 1/3 of x plus 5, find the measurement of arc BC. If measurement of arc BC is 4x minus 6 and measurement of angle C is x plus 10, find the measurement of angle EDC. I'd like you to pause the video, answer the question, and then look into my suggestions. Now, before we get into the solution, let's look into the concept. And the concept here is to look at the angles at the center. Now, as the diagram shows, the angle at C, shown in red, is half of the angle at the center formed by the arc AB. You get the idea. So AB forms an angle at the center which is twice the angle formed at C on the circle itself. So that's the theorem. Says the angle subtended by an arc at the center of the circle is twice the angle subtended at any point on the circumference. And the proof is very simple. You need to join the side, you need to join O to C. So we join this O to C. Let me just join and show you how it works out. So let us say we join OC. In that case, we have two triangles, OCA and OCB. These are isosceles triangles, right? Because we are talking about this radius, right? And therefore, the angles will be same. So let us say that this angle here is x. So that will be x. And on the other side, let's say this angle is y. So this angle will also be y, correct? So that is how you get your angles on both the sides as shown here. Now, what is angle AOC? So AOC is the angle which we are talking about, which is right there at the center. So this angle AOC is 180 minus 2x, correct? So angle AOC is 180 minus 2x On the other side, the angle BOC is 180 minus 2y. Perfect. So the central angle, which we are interested in figuring out, which is AOB, should be 360 minus the sum of the other two angles. Since at the center, total angle is 360 degrees. And once you substitute these values, what do you get? You get it is 2x plus 2y, or it is twice the angle x plus y. And angle x plus y is the angle at C itself. And therefore, we have proved that the angle subtended by the arc at the center of the circle is twice the angle subtended at any point on the circumference. We are going to use this property to answer our questions. Now, let us take the questions one by one. So, in the very first question here, we have measurement of angle EDC, which is EDC is this angle. So, measurement of angle EDC is 3x plus 10. And we are given that measurement of arc BC. So arc BC is right there. This is given to us as 2x minus 30, right? So that is the arc BC, and the angle here is 3x plus 10. Correct. So these two things are given to us. We need to find measurement of E to C. So this is what we need to figure out. So to find this, we have to find the value of x itself. You get the idea, right? So how do we figure this out? Now, if I know that the measurement of angle EDC is 3x plus 10, in that case, what should be the measurement of angle BDC? Well, that means that the angle BDC should be equal to 180 degrees minus 3x plus 10, correct? And we know that that should be equal to the arc BC, right? And this should be equal to the arc BC. So that arc BC, which is given to us as 2x minus 30, that should be equal, right? So from here, we can equate equation 1 with equation 2. Since we know that these are equal, is that equal? Perfect. So we have an equation to work with. So our equation now is 180 degrees minus 3x minus 10. So that comes from equation 1, and that is equal to 2x minus 30. This comes from equation 2, correct? 30, right? So we need to solve for x from here to get the solution. Perfect. So let us take the numbers in degrees on this side, and what we have here is 180 plus minus 10. So let me write down 180 minus 10, bring 30 to this side, and we have 2x plus 3x on the right hand side. Correct? So that gives you how much? So 180 minus 10 is 170, and 170 plus 30 is 200. So we have 200 equals to 5x, and that gives you the value of x as equal to what? 200 divided by 5, and that is half is 100 and gives us the answer as 50. Now once we know that this is 50, we have to find the measurement of EC. So measurement of EC is what? The arc EC is basically equals to 3x plus 10, right? 3x plus 10. So we can substitute 50 here and find our answer. Is that clear to you? So it is 150 plus 10, which is 160. And that is how we find the measurement of arc EC as equal to 160. Is that clear to you? So that is how we could actually solve this question. Extremely important question from test point of view. So we have 4 exercises very similar to one another. Now let's look into the second one now. It says measurement of angle BDC. So we are given this time BDC is 3 times x minus 5, and measurement of arc BC. We are also given measurement of arc BC, which is x plus 25. We need to find the angle E. So that is how we have to relate them. So we know in this particular case that 3 times x minus 5 should be equal to x plus 25. Is that point clear to you? So the angle and the arc, their measurements are same. So their measurements are exactly same. So from here we can find the value of x. Let's open the bracket. So we have 3x minus 15 equals to x plus 25. Bringing them together, we have 3x minus x equals to 25 plus 15. So we have 2x equals to 0, 4, or x is equals to 40 divided by 2. So we have x as equal to 20. Since we know that the value of x is 20, we can find the value E. Now, measurement of angle E is how much? It is half the measurement of angle D, right? I should write BDC, right? So therefore, it could be given as half of BDC, and BDC is given to us as 3 times x minus 5, where we know that x is 20. Substituting, we get half times 3 times 20 minus 5, correct? And that gives you the value as half times 3 times 15. And that cancels to give you how much? So 3 times 15, 45 divided by 2 is now the angle, right? So let's calculate this value, which is 45 divided by 2, or 22.5 degrees. So the answer here is that the angle E is equal to 22.5 degrees. I would like you to do your calculations so that you can check your calculations and even my calculations. But here is the concept that this angle E is subtended on the circumference, and therefore it is half the measurement of the central angle. So this is a very important thing which helps us to relate the two angles and then find the solution. So I hope this part is clear. Now let's look into the next example where we are given that measurement of angle E, that means this angle, is given to us as half of x minus 10. So that is given to us. And now we are also given that angle C is 1/3 of x plus 5. So angle C will write here, which is angle C is given to us as 1/3 plus 5. And we need to find the arc BC. So we need to find the third thing, which is this particular arc BC. Now, how do you do that? Well, this is an isosceles triangle, and therefore the two angles should be equal. And therefore we could write that half of x minus 10 should be equal to 1/3 of x plus 5. And now we can solve them. To solve, let us cross multiply, right? Let's cross multiply. So when you cross multiply, you get 3 times x minus 10 equals to 2 times x plus 5. Now some of you can also see this as times by 2 common factor. See, LCM in this case is 6. So multiply both sides by 6 on both sides. Is that clear to you? So that will give you the same result which you get from cross multiplication. Now let us simplify. Open the bracket. We get 3x minus 30 equals to 2x plus 10. Bring the variables together and constants on the right hand side. So we get 30 plus 10, and here we have x is equals to 40. So we get the value of x. We need to find what is BC. Now clearly the BC angle arc will be equal to twice the angle E, right? So we know, or you can find the central angle D. So we know that the measurement of arc BC is equal to twice the angle E, right? So to find angle E, I will substitute here. So measurement of angle E is what? Measurement of angle E is half of the x value of 40 minus 10, which is half of 30, and that is 15 degrees, right? So we know it is 15, and therefore the measurement of BC, which is twice 15, is our answer, and it is 30. Is that clear to you? So that is how we relate the two, correct? I hope this is absolutely clear, right? So let me just make it very clear. So we found the measurement of angle E since we know that x is 40 for us. Substituting 40, we found the value of E. Now E is half of this angle, and that angle is equal to the arc. And that's why we doubled it. Okay? Now let's look into the last example of this particular exercise. In this case, again, we have the same circle with the chords. We are this time given that the measurement of arc BC, this is given to us as 4x minus 6, and the angle C is also given to us as x plus 10. We need to find the angle BDC. So we have to now find this particular angle BDC. BDC, the other angle. Okay. Angle BDC is this one, right? So BDC is same as the arc BC, so we need to find this. Okay, so this is very clear. From here we know this is an isosceles triangle, so we know that the angle E should be equal to angle C, right? And angle C is given to us as x plus 10. And we also know that angle E is half of, so angle E is equal to half of measurement of BC, right? Measurement of BC. So that means that x plus 10 is equals to half of measurement of BC, which is 4x minus 6. Is that clear to you? So we do get an equation. We can simplify this, and we know what is half of 4x minus 6. It is 2x minus 3. Now bringing the variables together, we can actually solve this equation. So this time I'll bring this to right hand side the variables, which is 2x minus x, and so we get the value of x as 13 degrees. So x is 13 for us. Let me only write the number 13, and that gives you the value of x, and so we can now find d. So the angle, which is angle BDC, measurement of angle BDC is what? Angle BDC is twice angle E, correct? So we have twice angle E is x plus 10, right? So we'll substitute 13 to 10, and we get twice 23, and that gives you the angle of 46 degrees. Do you see that? So the arc length, so the angle which we need to find, BDC, is basically equal to 46 degree. Is that clear to you? So in these questions, what we have applied is the concept that the angle in the center is twice the angle on the circumference. And also, isosceles triangles have same angles, two of them. And this helps us to answer the questions which we started with, right? So in this triangle, you know always that these two sides will be equal, and the other one also, since they are the radii. And these two angles are equal since they are isosceles triangle. And we know that the angle, let me write down, angle BDC is twice the angle E. Is that okay? So that helps us to find all the solutions based on these 4 questions. I hope the concept is absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.
You can join my classes by sending an email on the address given and ensure bright future. Thank you. You may join my classes by sending an email to the address given. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.